Hey, welcome to part 3 of Intro to Vectors. We're going to do scalar multiplication, unit vectors with IJ notation, and the dot product. I can't wait. Let's do review first. All right, everybody likes to review. Remember when you're finding vectors from points, it's just the end point minus the beginning point. So B is the end, A is the beginning. So that'd be 21 minus negative 4 is 25, and negative 15 minus negative 8 is negative 7. Pretty simple. Keep in mind, at Socrative, if I ask for number 1, that's what I mean. Type the whole thing in. No spaces, please. When a vector is either vertical or horizontal, we don't want to make it hard. We don't want to do sine, cosine, or tangent or any of that. We just want to count. So that's 1, 2, 3 up. Component form would be 0, 3. And polar form would be 3 in the direction of 90 degrees. Moving on. Keep in mind when vectors are added, they are to be added in component form, not in polar form. So here are some rectangular or component vectors. Vector S, let's count that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So that is vector S. Vector W is just 1, 2, 3, 4 down. And then we would add the components, and the components add to be 7, negative 7. Moving on, kind of combining the concepts where we have some points and we got to get some vectors, and then when we add them. So vector BA is A minus B, 0 minus negative 3 is 3, 17 minus negative 10 is 27. And vector BC, that's B minus C, so that's negative 3 minus negative 1 is negative 2, negative 10 minus 20 is negative 30. And then we would add the components, and they add to be 1, negative 3. Then we did this problem. I'm not going to do this one in the review because it would take too long, but keep in mind you would not add the 600 and the 40. You would have to put the wind in component form and the airplane in component form, add the components, and then come back to the magnitudes and the direction. Scalar multiplication is just a continuation of vector addition. So let's don't make that hard. Here we have a vector and it's 2, 3. You already know that. It's 2 to the right, 3 up. So in component form, it's 2, 3. Not spectacular. And then if we were to take that vector and just kind of double its length, we could write that picture as the vector plus itself like this, or 2 times the length of the vector, 2 times the components. And then either way, you would get 4, 6. And then if you want to call that the distributive property 4, 6 and get 4, 6, you call it whatever you want. That's just a recap of that. We had that vector right there. That allows us to do a problem like this where we're taking U and tripling its length in the same direction. We really don't want to think of it in that way. Here's U, so it'd be negative 2, 3, and W is 8, negative 5, and then we'd multiply that, and it'd be negative 6, 9. I'm actually going to multiply in a negative 1 and make this addition, so it'd be negative 8, 5. That's negative 5 right there, not my best handwriting. And so this would be negative 14, 14 as a final answer. Keep in mind, that's what we'd put in at Socrative. No spaces, please. For number 6, it's kind of the same thing. I do like to have a negative scalar. So we're putting in, let's see, T is negative 4, 12, and V is negative 1, negative 7. Multiply in our scalar. So this would be 20, negative 60. And I'm going to multiply in a negative 2 and make this plus. So that would be 2, 14. And then we'd get a final answer of 22, negative 46. All right, the unit vector is all about similar triangles. Now, there's no way you got this far in life without being able to do similar triangles, so you may want to pause the video and see if you can come up with X. You ought to have a whole lot of success with that. Straight ratios, 8 is to X is 10 is to 6, cross multiply and come up with that answer, no problem. All right, there's vector U. There it is in component form. Let's do something with it. Let's look at that vector first. What's the magnitude of that vector? Well, that's tough. It is 1. Any vector on this that acts as a radius of this circle is going to have a magnitude of 1. All right, 1. We just said that. Definition, a unit vector, a vector with a magnitude of 1. Fantastic. V is the unit vector in the direction of u. Think about what that means. Pause, read, think. What is the x component of vector v? All right, it's not 1. See if you can come up with that. It's contained in similar triangles. We have this blue triangle that's got, we know all the pieces. We know the hypotenuse and the x and y piece. So we made a ratio of the magnitudes and a ratio of the x components, and we got that. I would allow either of these at Socrative if I asked for that. Now, the best answer would be -3 root 13 over 13. You know that. Moving on. See if you can find the y component. It's the same stuff. It's still similar triangles. All right, right there. Ratio of the magnitudes, ratio of the y components, and we get 0.55, or we could put in the exact answer at Socrative. And we have a formula that the unit vector in the direction of u is equal to 1 over the magnitude of u times u. Those symbols mean magnitude. There's your magnitude right there. All right, see if you can use that formula to come up with the unit vector in the direction of u. Well, everybody can do the magnitude. I mean, come on, it's finding a hypotenuse, and it's 37. So if we use this formula, it would be 1 over 37 times the vector, -12, -35. Now, that's actually a form of the right answer, but we're going to scale in the 1/37th. So it'd be -12 37ths and -35 37ths. Nice. I like that unit vector. I think we have one more of those. See if you can do that. Pythagorean theorem gives us 3 root 2 as the magnitude. So if we use that formula, it'd be 1 over 3 root 2 times 3 -3. That is an answer, but let's scale it in. So it would be 3 over 3 root 2 and -3 over 3 root 2. And then this simplifies to 1 over root 2 and -1 over root 2. Now, we probably shouldn't leave the radicals in the bottom, so it would be root 2 over 2, -root 2 over 2. And then that would be a final answer. I think we have a couple more things to talk about. By definition, this is the I unit vector right there. You should be able to write that as 1, 0. It's just in the direction of the positive x-axis. And the same there. And then the same thing for the positive y-axis. That's the j vector. And that's 0, 1. I want to look at that real quick and what that means. That if we were to write this vector and this vector, they can be written as the same thing or interpreted as the same thing. And this is why. Okay, that the I vector is 1, 0, and the j vector is 0, 1. And then if we scale in the 3 to the I vector and the 4 into the j vector, we'd get these, and then we'd add the vectors and get that. So all that comes down to is this is just another way to write the vector 3, 4. Let's don't make that hard, and let's be done with that portion. All right, we finally made it to dot product. Now, the result of a dot product is not a vector. It is a value. It's just a number. Here is the formula right here. And you just multiply the x components, multiply the y components. We probably would have thought to do that, but then you add the results. So these x components multiply to be 12, and the y components multiply to be 10, and 12 plus 10 is clearly 22. And that would be the dot product of those vectors. There's really no vector multiplication. There's scalar multiplication and there's dot product, but there's really nothing called vector multiplication. All right, pause the video and see if you can use that simple formula and to come up with a value. All right, so this product is -4, this product is -10. You add them and get -14. Again, your answer is a value, not a vector. Number 13, same thing. Pause the video, see if you can come up with the dot product of these vectors. This product is -3. This product is 25. The result is 22. All right, feeling good about a dot product. You're like, wow, that's easy. And it is. One thing you could do to a dot product, if you took a vector and you did the dot product to itself, it could help you find the magnitude. It would be -1 times -1, which is -1 squared, plus 8 times 8. And so that's 1 plus 64 is 65. Now, I'm not saying that 65 is the magnitude. It is the dot product. But if you took the square root of the dot product. It would be the magnitude if you use the same vector. Kind of a bit of trivia there. Hey, there's vector u and there's vector v, and they form an angle. That angle looks obtuse to me. Let's measure it. Hey, it is obtuse. It's 105 degrees. That is to scale. I blew it up. Trust me. All right, and here is a formula for the angle between two vectors. So that's the same two vectors right there. So we should get something close to 105 degrees. See if you can use that formula. This right here, let me see if this works today. That, yay, that is the dot product. And these are magnitudes. Keep in mind, those straight lines is not absolute value, it's magnitudes. I bet you can use that formula. All right, here we go. The dot product is right here, and it's -6. The magnitude of u is right here, and it's root 13. The magnitude of v is right here, and it's root 40. And then you just type that into your calculator, and lo and behold, we get about 105 degree angle. If we asked for that at Socrative, we would put in 105.26. I think we only have one more problem, which makes me sad because this is so much fun. I love vectors. All right, see if you can use the angle between two vectors formula. Again, dot product is -45. The magnitude of u is root 149. The magnitude of v is root 89. And then we just type that into our calculator. And then rounded to 2 decimal places, you could put 113.00 Socrative, or you could just put 113. You know, I give you options like that because I love you guys. All right, guys, I am sad because I miss you. See you later.